Hello everyone. Let us prove the following. In an equilateral triangle, prove that 3 times the square of one of the sides is equal to 4 times the square of one of its altitudes. Okay. So, given that triangle ABC is a equilateral triangle. What is an equilateral triangle? All sides are equal. Okay, and we can write that AB is equal to BC is equal to CA, right? And let us consider AD is one of the altitudes of that particular triangle. That means AD is perpendicular to BC. Okay, so what do we know? In an equilateral triangle, perpendicular drawn from the vertex to the opposite side, it bisects the other side. Kada? Ante AD is the altitude or the perpendicular drawn from A to BC. Obviously, it divides BC into two equal halves. Okay, so two equal halves ante BD is equal to CD అవుతుంది. Obviously, ఆ రెండు కూడా half of the BC ఉంటాయి అన్నమాట. Okay, so we can write that BD is equal to CD is equal to half of the BC or BC by 2, right? And one more point is given here. AD is perpendicular to BC, right? So if we clearly observe, we can see triangle ADC after drawing this altitude. Yes or no? So what does it become? Triangle ADC becomes as a right angle triangle, as angle D is 90 degrees. Okay, we have drawn a perpendicular, so it becomes a right angled triangle. Okay, so in this right angled triangle, right angled at D, we can say that AC is the hypotenuse and AD and DC are the two other sides. And one more point we can apply to a right angled triangle is nothing but Pythagoras theorem. What is Pythagoras theorem? In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, so now we are applying this Pythagoras theorem to triangle ADC, where AC is the hypotenuse and AD and CD are the two sides. Okay, now applying Pythagoras theorem here, we can write AC square is equal to AD square plus CD square. Okay, so we got this particular point from applying Pythagoras theorem. But as ABC is an equilateral triangle, what do we know? We know that AB is equal to BC is equal to CA. Now we are going to replace AC with BC. As all are equal, we can replace. Yes or no? Right? That is why we are replacing AC or CA value with BC. Okay. So after substituting the values, what do we get? BC square is equal to AD square plus CD square. Okay, but previously what did we prove? As just as it is perpendicular drawn from the vertex, it becomes CD becomes half of the BC. Yes or no? Now we are substituting CD as BC by 2. Okay, so as D divides BC into two equal halves, we can write CD as half of the BC. So again we substituted CD with BC by 2. Okay, now finally how does the equation become? BC square is equal to AD square plus BC by 2 whole square. Okay, right. Now we are simplifying. So BC square is equal to AD square plus BC square, BC by 2 whole square becomes BC square by 4. Okay, so for simplification, here BC is there, here BC square BC is there, so we are transferring this particular term to left hand side just for simplification. That's it. So BC square minus BC square by 4 is equal to AD square. Now we have taken LCM. Further simplification, what do we get? 3BC square by 4 is equal to AD square. Okay, again we are transferring this 4 to this side. 3BC square is equal to 4AD square. Okay, what is AD in triangle ABC? It is the altitude. Okay, and what is BC in triangle ABC? One of the sides. What should we prove actually in the given sum? We need to prove that 3 times of the square of any side should be equal to the 4 times of the one of the altitudes of that particular triangle. We have proved that only. If you observe, BC is one of the sides of the triangle. 3 times BC square is equal to AD is the altitude. 4 times AD square. Okay, so it is proved. What is proved here? 3 times of the square of one of the sides is equal to 4 times of the square of one of its altitudes in an equilateral triangle. It is proved by using simply Pythagoras theorem. Okay, and dividing this part, as it is the perpendicular drawn to the base of that particular triangle, we have taken a simple concept of dividing it into half. Finally, we have proved that 3 times of this the square of any side in an equilateral triangle is equal to the 4 times of the square of its one of the altitudes. Okay, అర్థమైంది అనుకుంటాను. థ్యాంక్ యూ.